Hello YouTube! Today we are looking into a very interesting question: how to prove that 0.9 repeating equals 1. And I have written it here as a question, but we all know that this equality is true. Most of the proofs out there from a mathematical point of view are not so correct, I would say. So things like 0.9 repeating equals 1 over 3 times 3, or 0.9 repeating times 10 equals 9.9 repeating, are both assuming already that 0.9 repeating equals 1. So they're both not correct, and we will look into a more detailed and correct proof. So we'll do something very different here, and let's see. Yeah. So let's define a sequence. x1 equals 0.9, x3 equals 0.99, x3 equals 0.999, and so on. And you know already where this goes. Xn equals 0.999. We are doing this n times, and after the nth 9 we are having just zeros. So we have n nines here in times. Okay, and let's define now 0.9 repeating as the limit of this sequence where x tends to infinity. Okay, I think this is obvious because when n is increasing we are having more and more 9s here, and this infinite times, so to say. And now, in order to prove that 0.9 repeating equals 1, our strategy is here to prove that the limit of xn is 1. And for this, as always, we are looking into the difference of 1 and this sequence and showing that the difference of them is tending to 0 if x tends to infinity. So before we continue, if you like this video and if you think this video is useful to you, please consider subscribing to this channel, like the video and comment down below. And of course you can help the channel growing more and more. So let's continue. As I said, let's take a look into the difference. X tends to infinity, and we are looking into 1 minus xn in brackets. So we are having n nines behind the dot, and after that we have only zeros. So when subtracting xn from 1, you see that we have a 1 at the 9th position, and after that we have just zeros, meaning 1 minus xn is 10 to the power of minus n. 10 to the power of minus n, which is the same as 1 over 10 to the power of n, has a 1 at the 9th position. This is a positive number. For this reason we can leave out the brackets, and it's easy to see that this sequence tends to 0 if n tends to infinity. So this is the same as x tends to infinity of 1 over 10 to the power of n, and this tends to 0. So just in one line we have proven xn tends to 1, and by definition 0.9 repeating is the limit of xn. We have just designed our sequence so that it tends to 0.9 repeating, and all in all we have proven that 0.9 repeating equals 1. So I'm planning to record another video where we are proving 0.9 repeating equals 1 by not looking into sequences directly, but looking into series. And in particular we are looking into geometric series in order to show that 0.9 repeating equals 1. So if this is interesting to you, stay tuned and see you next time.